What is T2 and T1 in MRI? So there is lots of confusion about these terms T2 and T1. So at first, the letter T comes from the time. So always remind that the T letter comes from the time. Now, where is the time come from? T1 and T2 are technical terms used in magnetic resonance imaging to describe the time between magnetic pulses and when the image is taken. So when the radio frequency pulse is given, then two relaxation process happens simultaneously but separately in the same time. Okay. So suppose about the CSF or fluid, this is a fluid tissue and there is a fat tissue in the brain. And now think about the CSF. So when you give the radio frequency pulse from the machine, the hydrogen nuclei in the CSF processes two relaxation process. The one is longitudinal relaxation or T1 and the another is T2 relaxation or transverse relaxation. So this relaxation process happens in hydrogen protons. These two processes are separate process, and these two process takes different times to complete. So each tissue or each hydrogen nuclei have two process after the radio frequency pulse, and these two process have two different times, and these two times are termed as T1 and T2. So I am not going deep, just I am trying to give an idea about T1 and T2. If I define T1, then it will be the time it takes for spinning protons to realign with external magnetic field, that is T1. I repeat, the time it takes for spinning protons, that means the spinning hydrogen protons or hydrogen nuclei to realign with the external magnetic field, that is T1 time. And now the T2, the time it takes for spinning protons to lose phase coherence among nuclei spinning perpendicular to the main magnetic field. So I repeat, the time it takes for spinning protons to lose phase coherence among nuclei spinning perpendicular to the main magnetic field, that is T2 time. So there is two things. So one is that the protons are realigning with the external magnetic field, and the another process is that the protons are losing their phase coherence. So I am not explaining details about these two things. So I think you have get an idea about the T1 and T2. So thank you. So every tissue has the T1 and T2 characteristics or T2 and T1 timings. So by using these timings of these tissues, the contrast difference is created in the image. So by using the T1 timings, the T1 weighted image is getted, and by using the T2 timings or T2 characteristics of the tissues, we get the T2 images. Now, the difference between the two relaxation process gives the difference between the contrast of the tissues. I repeat, the difference between the two relaxation process in a tissue or different tissues. Suppose that the CSF and the white matter are two types of tissue, but these two types of tissue have the difference T1 weighted signal. So in a particular time, we can differentiate between the white matter and CSF. And if you compare between the two images, so if you see these two images, that the first one is T1 and the second one is T2. And why this is T1? Because the T1 timings are used in this protocol, and in this protocol, T2 protocol, the T2 timings of the tissues are used to create this T2 image. So in these two images, look at the CSF, that in T1 weighted the CSF is dark and the T2 weighted the CSF is bright. So in T1, the TR is short and TE is also short. So that means that after giving the radio frequency pulse, and if we take the image or receive the signal quickly or short time, then the CSF will be dark. And in T2 sequence, the TR or repetition time and the TE or echo time is long. So if we want to get this CSF bright, we have to give long time to receive the signal, and then we will get this T2 image. So hope you understand the process. So always remember that the T1 and T2 are the timings, and the timing is of two relaxation process in a tissue. So every tissue have two relaxation process after the radio frequency pulse. Then the one is T1 and T2, and the MRI protocols are uses these timings to create different types of protocols and make the contrast differences between the tissues. So thank you very much.